Hey everyone, we're going to move away from expansion, and our lesson today is on factoring quadratics using the product sum method. Hey everyone, hope everyone's doing well. I'm currently sitting outside while I'm recording this lesson, so if you hear anything in the background, that's all it is. Make sure you get outside, and I hope you enjoy the lesson. Okay guys, take 5 minutes to do the do now and upload a picture of it to Google Classroom. Today's lesson's learning objective is for students to be able to explain how to factor quadratics using the product sum method and apply this method to whole number quadratic equations in order to find each equation's real number integer roots. The learning standard we're addressing today is to factor a quadratic expression to reveal zeros of the function that it defines. Here's a list of vocab that you guys are expected to know, so if any of it there's any confusions, please look them up and add these terms all to your glossary of vocab for the year. It might be helpful to make a Quizlet to learn. Okay guys, so I quickly want to discuss standard form versus vertex form. Standard form of a quadratic is ax squared plus bx plus c equals 0, where a, b, and c are real numbered coefficients, and x is the unknown variable. It's really important. I want you to keep this. This is what we're going to work on today, solving for x in situations where you have a quadratic in this form. And we've already gone over vertex form, which is a times the quantity x minus h squared plus k, where hk is the vertex. And note just that vertex form is the result of completing the square on a standard form equation. Okay, first we're going to look at an equation that we should be able to solve. Okay, let's take a look at quantity x plus 1 squared minus 9 equals 0. So if we were to solve that without doing anything else to the equation, how would you think to go about it right away? Most likely, you guys all knew where you were going. So we're going to combine like terms and break it down into something more manageable. So let's try that. So if we take the equation, the first thing we want to do is we want to get x plus 1 squared, that quantity by itself, to try to get to x itself. So we're going to add 9 to both sides. So now we're left with x plus 1 squared equals 9. So to get x by itself, we have to undo something, right? We don't want to expand that out because it's going to be more complex and harder for us to solve. So we can take the square root of both sides, and now we have x plus 1 is equal to plus or minus 3. And I'm really stressing that when you take the square root, you have both plus and minus, because 3 squared is 9. 3 times 3 is 9, and negative 3 times negative 3 is also 9. So now we have two separate equations, and you can separate them out to make it easier for you to see. So we have x plus 1 equals negative 3, and x plus 1 equals positive 3. So now if we take a look at both of the equations, subtract 1 from each side, we get two solutions. X can be negative 4, or x can be equal to 2. Okay, now let's look at another problem. So now we have an equation that is in standard form. So without changing it, how would you first start to look at it? Well, if we try the same method that we just tried, let's try to isolate and get x by itself. So let's add 8 to both sides. And now we have x squared plus 2x equals 8. So we could try to pull out of x. If we pull out of x, we have x, and then left inside we would have x plus 2 equals 8. But we can't just solve it from that because it's not equal to 0. We can't isolate both those terms like we have in the past. So now we're going to get into how we could solve these problems today using the product sum method. Okay, the first step of the product sum method is to make sure your equation is in standard form, ax squared plus bx plus c. So we're looking at the equation x squared plus 2x minus 8. It's alright the way it is, but it may be clearer, and I would suggest rewriting it in the form of x squared plus 2x plus parentheses the quantity negative 8, just to make sure we carry that negative throughout the problem. Next, step 2, we get to identify what a, b, and c are. So looking at the equation, a is the coefficient attached to the x squared term. So here that'd be 1. B is on the x term, which would be 2, and then c is negative 8. Okay, now on to step 3. So as this is the product sum method, we're going to be computing a product and a sum. So the product we're always going to compute is a times c, and our sum is equal to b. So in our case for our problem, our product would be a times c would be 1 times negative 8 equals negative 8, and our sum is equal to b, which is 2. Okay, so now we're going to find two numbers that multiply together to our product, negative 8, and add to our sum, 2. So because our product is negative, we're going to need a positive and a negative number. So let's try 1 and negative 8. So 1 times negative 8 is negative 8, but 1 plus negative 8 is negative 7. So that doesn't work, because negative 7 doesn't equal 2. So what if the 1 is negative and the 8 is positive? So negative 1 times 8 is still negative 8, all good. Negative 1 plus 8 is positive 7. Once again, doesn't equal 2. So how about 2, negative 4? 2 times negative 4 equals negative 8, and 2 plus negative 4 equals negative 2. It's close, but we need positive 2 as our sum. So how about we switch the negative and we get negative 2 and positive 4. So negative 2 times 4 is negative 8, and negative 2 plus 4 equals 2. So that is what we want. So right now, our factors we're going to move ahead with are negative 2 and positive 4. Okay, so now we're going to take our factors that we just computed and use them to break down the bx term from the original equation. So originally we had x squared plus 2x plus negative 8 equals 0. So now we're going to keep everything the same, except we're going to rewrite the 2x into 4x minus 2x, or negative 2x plus 4x. Order doesn't matter. So we'll have x squared plus 4x minus 2x plus negative 8 equals 0. And you can clearly see that 4x minus 2x is equal to 2x, and we're not changing the equation in any way. So now that we have the equation set up, we're going to break it down into two different parts to look at. So first we're going to take the first two terms, x squared plus 4x, and look at those, and then we're going to look at negative 2x plus negative 8. So from the first term, x squared plus 4x, what's the common term? What do these share? Both x squared and 4x have an x, right? So we can pull out an x, leaving us with x plus 4 in the parentheses, which we can quickly check. So x times x is x squared, x times plus 4 is plus 4, x plus 4x. So now we can look at the second side. We have negative 2x plus negative 8. So if we pull out a negative 2, the common term, we have x plus 4 in parentheses, and everything is still equal to 0. So we can see that now we have the like terms, x plus 4, and we have x minus 2 of those like terms. And just think of x plus 4 as any other unknown like term. It could be x, y, z, any of the above. But we have x minus 2 of those, so we have x minus 2 quantity times x plus 4 quantity equal to 0. And note, now that we have this factored form that we're going to use to get the roots, you can always double check by foiling it out just to make sure you come back to what you had at the start. Okay, so now that we have the factored form, we can just quickly solve for the roots. So we have x minus 2 quantity times the quantity of x plus 4 equals 0. So now if we set both of those terms equal to 0, we have x minus 2 equals 0 and x plus 4 equals 0, which results with x can be 2 or negative 4. So now, quickly going back to what I was talking about in the last slide, it doesn't matter the order that you put the x factors when setting up before you start getting your like terms. So before we put x squared plus 4x minus 2x plus negative 8 equals 0, but you can also just equally write x squared minus 2x plus 4x plus negative 8. You'll get the same answer. So here, if we look at the first two terms, x squared minus 2x, we can pull out an x, leaving us with x minus 2. And in the second set of terms, 4x plus 8, negative 8, we can pull out a 4, and leaving us with x minus 2 in parentheses. So now here the like term is x minus 2, and we have x plus 4 of that, so we have x plus 4 times the quantity of x minus 2. Since we have two quantities multiplied together, we set each equal to 0, leaving us with x minus 4, or x equals 2, which matches what we have above. So now that we've gone through a whole problem, I want you to try on your own on the problem below. 2x squared plus 13x plus 15. Okay, let's see how you guys did. So our equation we're trying to solve is 2x squared plus 13x plus 15 equals 0. Our A would be 2, our B would be 13, and our C would be 15. So our product of A times C would be 2 times 15, which would be 30, and our sum would be B, which is 13. So now we need to find the factors that multiply to our product and sum to 13. So there's a couple ways you can go about it. You can just guess and check and see if you need to pick a factor that's lower or higher depending on your sum. You can make a factor tree if you're having trouble. I just went guess and check here. So let's see if let's try 6 and 5. 6 times 5 is 30, which is good, which is what we want. But 6 plus 5 is 11, which is not 13. So how about we try 10 and 3? 10 times 3 is 30, good, and then 10 plus 3 is 13. So that's all good. So we're going to have our factors be 10 and 3. So now we're going to break down our equation 2x squared plus 13x plus 15 equal to 0 into 2x squared plus 10x plus 3x plus 15 equals 0. So out of that first two terms, we can pull out a common 2x. So then we're left with x plus 5. And then from the last two terms, 3x plus 15, we can pull out a positive 3, so plus 3. And we are left with x plus 5, also in the parentheses. So now that we have like terms, which is what we want, we have 2x plus 3 of that quantity x plus 5, resulting with 2x plus 3 times x plus 5 equals 0. So now we can set both of those terms equal to 0. So we have 2x plus 3 equals 0, and x plus 5 equals 0. So from the first term, we subtract 3. We have 2x equals negative 3, so x equals negative 3 over 2. And in the last x plus 5 term, we have x equals negative 5. So the roots, or also known as the zeros or solutions, are negative 5 and negative 3 over 2. Okay, for today's exit ticket, take 10 minutes, answer the questions below, and upload a picture or a document to our Google Classroom site. Okay, I put some problems down for group work that you can access on Model with your partners assigned already, and the 5 problems below for independent work for homework you can submit to Google Classroom as well.